I believe everything comes down to love or science. And when I'm not falling for one, I'm obsessing over the other. This is Love Science, where we talk science out of love. I'm your host, Jay Jung. Have you ever wondered why your skin tans or burns in the sun? Or why sunglasses exist at all? Or what exactly SPF means on a sunscreen bottle? Today we're talking about UV radiation. It's invisible but powerful. It helps our bodies make vitamin D and also gives us sunburn. It's the reason the ozone layer matters, why reptiles bask in rocks, and why dermatologists constantly remind you to wear sunscreen, and yes, even on cloudy days. In this episode, we'll break down what UV radiation really is. We'll talk about where it sits on the electromagnetic spectrum, why some animals can actually see it, how it affects your skin on a molecular level, and what makes some materials like melanin or even your sunglasses so good at blocking it. And yes, I'm going to get a little nerdy about, photons, DNA damage, and all that cool science. But I promise it is cool science. Cool like SPF 50. So grab your shades, we're stepping into the sun scientifically. So UV radiation, short for ultraviolet radiation. It's a type of electromagnetic radiation like visible light, X-rays, or radio waves. But unlike visible light, we can't see UV. It's just beyond the violet end of the rainbow, hence ultraviolet. The electromagnetic spectrum is like a lineup of all light arranged by wavelength. On one end, you got long lazy waves like radio and microwaves. Then comes infrared, visible light, UV, X-rays, and finally gamma rays. The shorter the wavelength, the higher the energy. So UV is higher energy than visible light, but not as wild as X-rays. That energy, that's what makes it special and dangerous. The sun is our main UV source, and not all UV is equal. There's UVA, the longest wavelength, deeper skin penetration. UVB is shorter, higher energy, causes sunburn. And UVC is the most intense, but mostly blocked by the ozone layer. Thank goodness. When we damage with CFCs, the chlorofluorocarbons, the refrigerants and aerosol propellants, like the biggest source of greenhouse gas, skin cancer spiked, when the ozone was attacked. Coincidence? I think science. So when you're sunbathing, it's mostly UVA and UVB you're soaking it in. It feels warm and gentle, but it's not harmless. So what actually happens when UV hits your skin? Let's start with the UVB, the shorter wavelength, higher energy type. It damages your DNA directly by forming these thymine dimers, weird bonds between neighboring DNA bases that mess up replication. If your cells can't repair them properly, mutations can build up, and that's how we get skin cancers like basal cell, squamous cell, and melanoma. UVA, on the other hand, goes deeper into the dermis. It doesn't directly alter the DNA, but it generates reactive oxygen species, or ROS. These are unstable molecules that damage proteins, membranes, and DNA indirectly. It's like oxidative chaos, leading to aging and long-term cell stress. Now here's something people mix up all the time. Suntan versus sunburn. They're related, but not the same thing. A suntan is your body's defense mechanism. When exposed to UVA, your skin produces melanin, the pigment that absorbs UV and disperses it as heat. That darker tone, it's your skin trying to protect you. A sunburn, though, is injury. UVB causes inflammation, redness, pain, and even blistering. That's your immune system reacting to damaged cells. So tan is adaptation, burn is damage. And both mean your skin has been stressed enough to mount a biological response. One's a warning sign, tan, the other is a cleanup. And here's a stat that always gets me. Just one blistering sunburn in childhood or adolescence can almost double your risk of developing melanoma later in life. UV exposure builds up over time. Your skin never forgets. So the next time you're in the sun, remember, it's not just warmth. It's radiation, and your skin is doing its best to fight it. Cue the sunscreen. Chemical filters like avobenzone absorb UV. Physical filters like zinc oxide, it's like a white powder, reflect it. SPF, sun protection factor, means how much longer you can stay in the sun without burning compared to unprotected skin. SPF 30 doesn't mean just 30 minutes. It's a multiplier. So a minute without sunscreen in the sun equals to 30 minutes with the SPF 30 sunscreen on. Just a disclaimer, don't just take the number for what it is because it assumes that you have applied the sunscreen completely all over your skin. So better safe than sorry when you apply. Sunglasses. They do a lot more than just blocking glares. Quality sunglasses protect your eyes by filtering out UVA and UVB radiation using materials like polycarbonate or CR39 plastic. These lenses are often treated with UV-absorbing compounds or coated with anti-reflective and polarized layers that prevent harmful light from reaching your retina. What makes some sunglasses so expensive is my next question. Usually a mix of lens technology and optical precision. Higher-end sunglasses tend to have multi-layer coatings, better polarization, scratch resistance, and more accurate lens curvature, which reduces distortion. So you're not just paying for a logo, you're often paying for a better UV protection and visual clarity. Your eyes matter, as you see. So when you grab your sunglasses, think of them as mini optical labs, shielding your eyes one photon at a time. Also, this podcast is not sponsored by any sunglass brands or anything. If there is, I'll of course disclose it, but no, not yet. Okay, let's flip the narrative for a second. We've been talking how UV radiation damages our skin, causes cancer, and makes us bust out of sunscreen. But here's a twist. We actually need a little UV radiation. And why? Because it helps our bodies make vitamin D. So how does this work? When UVB rays hit your skin, and yes, specifically UVB, they trigger a reaction in a molecule called D7-dehydrocholesterol, which is naturally present in your skin. This molecule absorbs the UVB energy and converts to pre-vitamin D3. That then rearranges itself to vitamin D3, the form that can enter your bloodstream. And the rest is history, or chemistry. So yeah, without sunlight, your body can't make vitamin D on its own. It's literally a UV-powered nutrient. But, and this is important, you don't need much sun to make enough vitamin D. Sources say like 10 to 15 minutes on your arms or face a few times a week might be plenty, but this of course depends on your skin tone, your age, location, and even the season of the year. Too much sun? Risky. Too little? Deficient. It's all about balance. Nature's just tricky like that. We know us humans can't see UV, but what about others? Some animals can see UV and they actually utilize it. Bees use it to find flowers. While we have 3 types of cone cells in our eyes for red, green, and blue, hence RGB, bees have 3 too. But theirs are shifted. Instead of red, green, and blue, bees see green, blue, and ultraviolet. That means they can see patterns on flowers that are completely invisible to us, like UV landing strips that guide into nectar like airport runways. Birds take it even further. Many bird species have 4 types of cone cells, including one is sensitive to UV. Their eyes also have transparent oil droplets in the cones that filter and fine-tune the light, enhancing contrast. This helps them detect subtle differences in feathers, mate signals, and even urine trails. Yes, really, yeah. Let us pray. So while we think of UV as something we block, for bees and birds, it's a whole hidden color channel they rely on. It's like the world has an extra dimension of color. Jealous? I kinda am. Let's turn the globe for about 8,000 miles from the United States where I'm recording this, and let's talk Korea, where I'm from. Heard of, some umbrellas, yangsan, giant visors, sun cap, it's a Konglish, and arm sleeves, people wearing long sleeves in 35 degrees Celsius or 95 degrees Fahrenheit heat. This is SPF and foundation. People are serious about sun protection. Yes, part of it's aesthetics, but there is a historical reason. Since centuries ago, you can trace back to medieval or ancient Korea, untanned skin was a sign of nobility, as all the peasants, be it farmers and workers, were all tanned because they're working outside. but it's also smart science. UV causes aging, spots, cancer. Avoiding it isn't vanity, it's strategy. And, those big hats, sun cap, my aunt wears, honestly, I want one right now. Big shade, big brain. So, whether you're lathering up with SPF, hiding under a sun hat, sun cap, or just now learning how UV works, congrats, you're now scientifically sunspot. I want to know now, how do you protect yourself from the sun? Are you a visor person? Are you like a known sunscreen, known piece type? Drop your stories in the comments or share it around. And here's a spicy questions to leave you keep thinking. If we need sunlight for vitamin D, but also need to block UV to avoid skin damage, should we chase the sun or hide from it? How do we keep that balance? Let me know what you think. This was Love Science, Episode 3, UV Radiation. I'm your host, Jay Jong. And thanks for spending a few rays of curiosity with me.